Alright guys, so today we're just going to do a brief review on some skills that we're going to need for working with vectors. So the first one, we're taking it back to grades 10 and 11. We're just going to do Sohcahtoa. So remember, Sohcahtoa is only for right angled triangles. And if we're trying to find angle A, we need to label our sides based on that angle. Opposite and adjacent means that we're going to use tangent, and tangent is equal to opposite over adjacent. Now for our vectors units, you're actually going to want to be in degree mode rather than radian mode. So just make sure you're in degree mode here. And you're going to do tan inverse on your calculator, and you should get 32.5. We're rounding to the nearest tenth here, which is 1 decimal place. All right, for the next one here, we have adjacent and we have hypotenuse, which means we're going to use cosine. So cosine is equal to adjacent over hypotenuse. You're going to multiply that 15 up. And we're rounding to the nearest hundredth here. So let me just calculate quickly here. This would be 10.97 centimeters. Okay, again, for this one, you also want to be in degree mode. Okay, so important things to remember here is that Sohcahtoa is only used for right angled triangles. Same thing with a squared plus b squared plus c squared. So if you know two sides of a right angled triangle, you can use a squared plus b squared to find the third, and that's only for right angled triangles. Now just to recap sine law and cosine law, this is sine law here, and we're going to use sine law anytime we have some unknowns in a triangle that's not a right angled triangle that we're trying to solve for. And in order to use sine law, you need to know an angle and its opposite side measurement. So I need to have some kind of pairing. If this is A, B, C, I need to know, let's say that this is 40 degrees, and I would need to know the measurement of its opposite side. So let's say 6 centimeters. If you have that plus an extra angle or an extra side, you can use sine law. If you don't have that pairing, you're going to defer to using cosine law. And this is when you don't know an angle and its opposite side. So two scenarios that you could have in this case would be that you know two sides and the angle in between them. So it's called a contained angle, sometimes called an included angle. Or you know all three side measurements. Again, these are only really necessary to do if it's not a right angled triangle. Okay, so these are the two versions of cosine law here. They're just rearranged versions of one another. It's really just the same formula with different things isolated. So for instance, this one, I would use if I know all three sides and I'm looking for an angle. And this one I will use if I know two sides and I have the angle that's in between those two sides, the contained angle. Okay, so we'll try those things out here. Find the measurement of angle P to the nearest degree. Now I'm seeing here that we have a side and its opposite angle measurement. So automatically I know that I'm using sine law here. So I'm going to set it up. Remember, we always also label sides with the lowercase letter of their opposite angle here. So this would be side little q. Sorry. And this guy here is going to be side little p. And we're trying to find angle P. So the other thing about this formula is that you only use two pieces at once. So you'll only use like that piece or this piece. And you can flip the formula any way. So if you're looking for a side measurement, you can keep it this way. But if you're looking for an angle measurement, you can actually switch it around like this. As long as you switch both sides, the ratio still remains the same. So I like to switch it around like this when I'm looking for an angle so that the angle is in the numerator. Just makes it a little easier to isolate. So I'm going to do that here. I'm going to set up sine of q over side little q, not p. And I'm going to set up sine of p over side little p. Okay, so uppercase represents angles, lowercase representing sides here. Okay, so the nice thing about putting the angles at the top is that it makes the isolating process much quicker. So we'll just multiply up to 10. And then we'll have sine of p equals, and then you can calculate in your calculator. So 10 sine 53 divided by 8. And then you're actually going to sine inverse that answer. Okay, and we are rounding here to the nearest degree. So that would be 87. Now, one thing to remember when you're using sine law is that the angle across from the additional side that you know can sometimes be an ambiguous case of sine law where it has two options. So if you're ever solving a question where you have to do sine inverse of a positive answer like we just did, so for instance, when you put in 10 sine 53 over 8, you'll see it was like positive 0.9 something. This actually technically has two possible answers to it. So with the ambiguous case of sine, you do need to make sure that you consider that. This would be like case number 1. And this is mostly if we're not given a diagram. So if we're not given a diagram and we don't know whether this is acute or obtuse, we would have to consider a case 2. And that case 2 would be essentially to find the other option for angle P, you do 180 minus case 1. And this allows us to consider both potential options. This is the only time where we would consider that there might be another case for angle P. And a lot of times we can tell if there's a case 2 by simply finding the third angle in case 2. So if I know Q and I know P now, I can find angle R by doing 180 minus 93 minus 53. And this will confirm to me whether we have a second case or not if I get a positive answer here. So I get an answer of 34 degrees for R. So that is a possible answer for angle R. So that means that there is a case 2 here. And that case 2 is that angle P could also be 93 degrees. Now, if your diagram is to scale, you could actually technically measure that diagram with a protractor and see what that angle actually is. So with case 2, the other option that you could have gotten here is that your angle R would have been negative, which would mean we discount, which would mean we discount the entire case 2. But because we got a positive angle for angle R, this is a potential case. So we actually have two possible answers here. Okay, unless it tells you specifically that you only have like an acute option for angle P, you need to consider that obtuse option as well. Okay, and this would be the only scenario for sine law that we need to do this. If I have two angles and one side, I don't need to consider a case 2 for sine law. It's only if you have one angle, its opposite side, and an additional side. Okay, find the length of E to the nearest hundredth. So this is little e. Across from angle D is little d, and across from angle F, lowercase f. So here I have two sides and that included angle or contained angle that we talked about. It's in between the two sides that we know. So I'm going to use cosine law. And cosine law says that the side that we're looking for squared is equal to the other two sides squared and added minus 2 times the other two sides. times the cosine of the contained angle. Okay, and once you get your answer for that, you can just square root the whole thing. So you guys can take a second to plug that into your calculator. Feel free to pause the video if you'd like. And we should get out from this answer right here, 560.78 whatever. You're going to leave that right in your calculator there, and should get out if it's nearest hundredth, you should get out 23.68, and that will be in centimeters. All right. The other thing that I just want to talk about is like finding angles within the quadrants. So some questions that you'll see in your worksheet for today talk about like finding certain angles between certain arms. So in this one, it says the initial arm is on the positive x-axis. Draw the angle below and find the measurement between the angle and the positive y-axis and the angle from the initial arm. So this is asking us to draw 50 degrees past the negative y-axis in the fourth quadrant. So here we have the positive x-axis, the positive y-axis, the negative x-axis, and the negative y-axis. So our angle is starting from the orange line here. Oops. Our angle is starting from the orange line here and going past 50 degrees into the fourth quadrant. So if we rotate this way, approximately 50 degrees, we know that this guy is 50 degrees here. This is our angle right here. And then it asks us to find the measurement of the angle between the positive y-axis and our angle. So I want this rotation. So remember, this is 90 degrees and 90 degrees. So if I'm looking for this slice in here, I'm going to do so the angle from the positive y-axis, maybe we'll call that theta, is 90 plus 90 plus 50. So in other words, 180 plus 50 will give us 230. Okay, and then the other angle that we're being asked for is the angle from the initial arm, which we said in the question was on the positive x-axis. So interested in this rotation to our angle here. So that's just another 90 degrees. So the angle from the positive x-axis, or the initial arm. This is usually measured in a counterclockwise direction, which is why I'm simply not calculating this. So maybe we'll call that x. I'm just going to take 230 and add another 90 to that to get 320. Okay, and that's everything.